question 13. The question said, draw the flow net for seepage under the structure shown in the following figures, which is here. Okay. And determine the quantity of seepage, okay, from upstream to downstream. The coefficient of permeability of the soil is this number that we have here. So we ask you also to determine the uplift force on the base of this structure. So we want to determine two things. The first one is the quantity of seepage. The second one is the uplift force. Okay, we know in order to solve this question, we should draw our flow net. So I draw my flow net, as you can see here, and in this flow net I choose my datum to be here at the bottom of what? Of the dam. Why? Because it will make my calculation easier. But anyway, you can have your datum anywhere, and the most important thing is your datum must be horizontal, as we know. Okay, then I start drawing what? My first flow line, okay, which is the shortest one, and here the longest flow line, which is here in this boundary, okay, and then the intermediate one, as I told you in the lecture, and then after that we start having the equipotential line, and this equipotential line, as we said, what we want to have a square grid, yes, and the equipotential line and the flow line must be perpendicular. Definitely the one that I draw here is not perfect, and it's very hard to draw a perfect flow net, as we said, but we do our best because this is hand sketching at the end of the day. Okay, then we said, what is the total height here? Okay, the total height here for this equipotential line is the elevation, and the elevation is 0. The elevation here is this number, which is 2.5, because this is the datum. So the elevation of this line is 2.5, plus what is the pressure head? Is 3. So the total pressure head here is 5.5. And what we have here is 2.5 for this exit equipotential line. And we don't have any elevation, so this is why we don't have any pressure head, so it is 0. So the elevation is only 2.5. Okay, so upstream we have 5.5, downstream we have what? 2.5. Then how many drops do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Then we can divide now the difference between the total head in upstream and downstream, okay, by these 8 steps, and we can now say, yeah, this line has total head equal to 5.125, this one having total head equal to 4.75, and so on, as we can see here. Okay, to get the first requirement, which is what we said we want to have Q, and this Q now, from the equation that we know, it is in F divided by N what? Divided by N D, okay, times K times H. Okay, NF is known, it is 1, 2, 3. In D, which is number of drops, it is 8. It is 1, 2, 3, 4, 5, 6, 7, 8. K is already given. H, which is the difference between the upstream and downstream, then we can get now Q, and remember this is only per linear meter of this dam. So if we take 1 meter like that, so this is the Q per what? 1 meter perpendicular to this page. Okay, then the second requirement was the uplift force. So the uplift force, what we can have here is the pool water pressure. And the pool water pressure is going to push this dam up. So let us see here, do we know what is the pool water pressure here and here and here and here and here? Because this is actually what the flow net can help us to do, which is determining what the pool water pressure at the bottom of this dam. Okay, so I know what is the total head here, which is 4.75, and I know the total head, we said before, total head is equal to what? Equal to elevation plus pressure head. Okay, so because all of these points that I have here, okay, on the datum already, so it doesn't have any elevation head. So this value will be the pressure head. So now if I multiply the pressure head by gamma water, I will get the pool water pressure at this point, pool water pressure at this point, pool water pressure at this point, and so on. So I will get the distribution of the pool water pressure underneath my dam. So if I get the average value of this pool water pressure that I have here, just all of these values that you have, okay, get the average and multiply the average by what? By 8 times 1, you get the uplift force. So again, it is the average what uplift pressure. What is the uplift pressure? It's the pool water pressure. So we get the pool water pressure using this equipotential line, because this equipotential line can tell me what is the pressure head at any points. So then I multiply it by gamma water. Okay, we know pool water pressure is equal to what? Pressure head times gamma water. So I get the value for all of these points, get the average multiplied by 8 times 1, give you the uplift force. Thank you very much.